Okay, this is the Platform9 Managed Kubernetes UI. What we can see here is the clusters view. It shows two clusters. The first one was deployed to AWS, and the second one, called Local One, was deployed to on-premises bare metal machines. And Local One has one master node and two workers, whereas the other one has three masters and one worker. Okay. There's also a nodes view, and let me show you how easy it is to deploy a new cluster to a cloud account, such as AWS. The first thing you need to do is register a cloud provider account. This basically means register your API keys. In this case, we've already done that, and we have something called hybrid dev. And once you have that, you just say add cluster, auto deploy, select your cloud provider, select your region, and follow the wizard. Okay, and one of the things the wizard will do is allow you to select availability zones from that region. We recommend that you select all availability zones so that the cluster is highly available. PMK will configure a cluster by spreading multiple master nodes across availability zones so that if you lose one availability zone, your cluster continues to run. Okay, I'm not going to finish the wizard, but it typically takes between 5 and 10 minutes to create a cluster that way. What I'm going to concentrate on today is this local cluster, which I've already created before, but what I'm going to show you is how to add a node to that cluster. Okay, so we already have two worker nodes, and we're going to add a third one. So for bare metal machines, the way it works is you first need to have a machine running Linux. We support either Ubuntu or variations of the Red Hat Linux. You download an installer, you install it on the Linux machine, and that will automatically start the agent and connect the agent to the management plane. And at that point, the node will appear here automatically. All you need to do is authorize it. And now it becomes available as a node that has not been assigned to any cluster yet. See, it shows up right here. Let me refresh. And it's going to read the internal IP address pretty soon. There you go. So its IP address ends with a 97. So in order to attach it to an existing cluster, it's very easy. We select it here, attach to cluster, local one. Before I do this, let me switch over to the CLI. PMK is a CLI that we give you, and it allows you to manage the management plane. So you can see everything here, nodes, clusters. Kube control, on the other hand, is the Kubernetes CLI, and that one is configured to talk to a specific cluster, and in this particular case, it's configured to talk to local one. So if I say get nodes, I will see that local one has one master node and two workers. Okay, so let's go back to the UI, and we're just going to attach that new node. Also, on the bottom left here, I have a little bash script that runs in a loop, and it continually prints out the worker nodes belonging to that cluster. Okay, so pretty soon you should see a new worker node being added here. Yeah, there it is, 97. Okay. One more thing I'd like to show is once you have a cluster, you have several useful links, such as downloading a configuration for the kubectl utility. You can also click on Dashboard, and that will bring up the UI for that particular cluster. Okay, so you can see all the Kubernetes resources, pods, jobs, etc. Okay. Okay, so now I'd like to demonstrate something that shows the power of Kubernetes and PMK when they're combined together. And it's a high availability scenario for an application. This application is a sample app that we developed. Okay, it's on GitHub and you can download and deploy it yourself. The idea of this app is it simulates think of it as an embedded device that doesn't have many resources, and in particular it doesn't have a system clock. So it has to continually send a request to a time service in order to get the current time. And we've wired this time service to a Kubernetes service, which, remember, acts as a load balancer distributing requests to a set of pods, in this case pods of the time server type. And this app will make 3 requests per second, and if it has more than 2 errors within 3 tries, then it'll show the status as down. Okay, so right now the service is down, and to start the service, what we're going to do is create the service, but right now nothing has happened yet because the service has no endpoints. Okay, and the reason there are no pods running yet. So to correct that, we are going to create the deployment. And by the way, the YAML files here are in the GitHub repo, so you can look at them. So now we started the deployment, and what the deployment does initially is ensure that there's always one pod of that type running. So now you're seeing requests succeeding, and now the status becomes green. Okay? And we see that there's one time server pod running. So what happens if we kill that pod? Since it was the only ones implementing the service goes down. However, remember that the deployment is smart. It remembers what you told it. You told it, I want one pod running at all times. So it will automatically spawn a new one. Okay? But we had some disruption in service. To ensure that we have no disruption, what we're going to do is scale the deployment to 3 or more pods. So what you should see is as the 2 new pods show up, you're going to see 2 new colors being added to the set of requests. See? So we've got green, pink, and there should be one more coming up. Yellow. Okay. So this is, again, Kubernetes in action. It has this service construct which automatically detects the pods implementing the service and will distribute requests to them. One thing I did was write a script that shows you not only the pods, the time server pods, but also what nodes they're running. So you can see that right now the 3 pods are evenly distributed across the 3 nodes. So now we have much better availability for the service. In particular, if a node goes down, this overall service should still stay up. And in order to demonstrate that, I'm going to show you a PMK rolling upgrade of the data plane. So what this means is once in a while there will be a new Kubernetes version or a new Docker engine version or some bug fixes or even future enhancements to the Platform9 agent. All of these software components run on the data plane. So in order to upgrade the data plane with minimal downtime on applications, what PMK does is it does a rolling upgrade of nodes in the sense that it starts with the first node, puts it in maintenance mode, and tells Kubernetes to tear down any pods running on that node and then reschedule them somewhere else. Okay? So we're going to initiate an upgrade or simulate the upgrade with something called a restart. And when I start this process, I want you to pay attention to the bottom left. Remember that the bottom left shows you the status of worker nodes. And look at the colors here on this bottom right. So soon enough, you'll see that node 95 is being taken down for maintenance. And then the pod that was running on 95 has disappeared. But not just that, Kubernetes detects the node downtime and it automatically respawns that pod on a different node. So now we have two of them running on 97. And you should also see the disappearance of one color and the appearance of a new color here. But in the end, you still have 3 pods running. Now those 3 pods are running on 2 nodes. Okay? And the rolling upgrade will continue to work in this manner, and it will service every node until it runs out of nodes to process, at which point the upgrade is complete. So this example shows that combining this feature of PMK with the power of Kubernetes allows you to do planned maintenance on your infrastructure with zero or little downtime on your applications if they're designed with the right abstractions. Okay? And since this is going to take a while to finish, I think this is a good time for me to start taking questions.